See, most of the time, even the consultants make mistake in selecting the design area. We already know that the remotest area will be the hydraulically most demanding location or area to be considered for performing the hydraulic calculations. But what should be the length of that remotest area? What should be the width of the remotest area? Here is the confusion. And if the sprinklers are spaced uniformly, then how to select the design area? And if the sprinklers distribution is non-uniform, then how do we need to select the design area? And if you have various hazards, like in the same floor, you have in the remotest floor, you have various hazards, like you have ordinary, extra, as well as light hazard. Then how to select the design area? All these considerations has to be kept in mind when we select the design area. So in today's session, mostly I will explain about the design area requirements, or how to select the design area, how to select the length, how to calculate the number of sprinklers, and also if the sprinklers are spaced non-uniformly, what is the requirement? And I will say about different scenarios on selecting the design area for performing the hydraulic calculation. Apart from that, we will also check if we use quick response sprinklers, if you use high temperature rated sprinklers, and if there are sloped ceilings, what is the requirement? If we consider pre-action system in our project, how to perform the calculations. It means how to select the design area, or how many number of sprinklers has to be considered. Everything we'll look into today's session. So this will be an important session. So if you are having any doubts, please interrupt me and ask me, because you have to understand this concept in order to correctly perform the hydraulic calculations. Because as I said, most of the designers, most of the consultants confuse with this design area requirements. So everything will be in accordance with NFPA 13. So let's start with our first scenario. If I ask you, like, how many sprinklers should be assumed to activate during a fire? Or for example, just a moment, I will take which color, just a moment. I think you can see the screen, right? I hope you can see the screen. So before we move ahead with the design area requirements, we have to remember few things. Again, I'm repeating few things here because these are important to select the design area in accordance with NFPA 13. So the first point will be the design area requirements, which I am explaining here, is applicable to CMDA sprinkler, extended coverage sprinkler, and standard sprinklers. CMDA is for storage hazards. We can use a CMDA sprinkler, which works on density area method. Okay, extended coverage sprinkler, like extended coverage upright, extended coverage pendant, or extended coverage sidewall sprinklers. If you have in your project, we can consider the procedure which I'm explaining you now. If you have standard sprinklers, then also like standard upright, standard pendant, and standard sidewall sprinkler, then also we have to consider this procedure only. If you have like CMSA in your project, CMSA sprinkler, this is used for storage hazards. Okay, and also, for example, you have ESFR sprinklers. This is also used in the warehouses, like where we have storage hazards. So that time we'll use ESFR sprinkler or CMSA sprinkler, or we can use CMDA sprinkler. But for CMDA, we will follow the same requirement. the one which I'm going to explain you now. But for ESFA and CMSA sprinkler, ESFR and CMSA sprinkler, the procedure is different. So we will cover today the design area requirements for CMDA extended coverage and standard spray sprinkler. This is the first point. And second point, you already know, like for non-storage hazard occupancies, we will define the hazard occupancies into three categories, right? Light hazard, ordinary hazard, again group 1, group 2, extra hazard, group 1 and group 2. So the design area requirement based on the density area curve. So the design area requirement will be 1500 GPM and the density for light hazard is 0.1 GPM per square feet. This is the standard design area to be considered. Sorry, the design flow and design density to be considered for light hazard occupancy. Sorry, not 1500 GP. I'm so sorry for this. 1500 square feet. Okay. So based on the area density curve, we already gone through the area density curve. So based on area density curve, we will consider 1500 square feet design area with 0.1 GPM per square feet for the purpose of calculations. For ordinary hazard group 1 and group 2. For ordinary hazard group 1 also we will consider 1500 square feet design area for performing the calculations. And the density for ordinary hazard group 1 is 0.15 GPM per square feet. For ordinary hazard group 2, the design area of operation is 1500 square feet. But the density will be, you have to remember these things. These are the basic concepts to enter or to for calculating the flow requirements. You need to know these requirements. So ordinary hazard group 2, 1500 square feet at 0.2 GPM per square feet density we need to consider. For extra hazard, 2500 square feet at 0.3 GPM per square feet density. And for extra hazard group 2 also we need to consider this requirement, 2500 square feet at 0.4 GPM per square feet. If you go through NFPA 13, you can just find the density area curve, which we already discussed several times in our sessions. So density area curve, you will find all these details. So you have to remember these things. Okay. And the third thing is like, the formula flow is equal to design area into density. We can calculate the flow from sprinkler or total flow requirement based on the design area multiplied with the density. So this is based on the area density curve. Okay, so design area is calculated by, we already know, like, just a moment, I'll take some other color. We know the design area for light hazard is 1500 square feet, ordinary 1500 square feet, and extra 2500 square feet. When I'm talking about the design hazard area, it means like this is the remotest floor. For example, our piping is coming from somewhere this side and it is going towards this. So our design area will be the remotest area which we consider for performing the calculations. Otherwise, we can say like this area sprinklers will be activated during the event of fire. Okay. For example, here the fire occurs. Only this design area sprinklers will be activated initially to suppress the fire. In case the fire is not controlled, then the other sprinklers will activate once the smoke or heat reaches to that particular sprinklers. So basically this design area refers to the sprinklers which will be activated during a fire. Okay. So if we consider the remotest area, then if the water reaches to the remotest area, the water can reaches to the other area as well, right? If the water reaches with the required pressure in the remotest area, obviously the water reaches to the other areas with the more pressure requirement. So the design area will be these things which I am explaining on the board here. So 1500 square feet for light hazard, 1500 square feet for ordinary hazard, and 1500 square feet to be considered for the, 2500 square feet to be considered for the extra hazard. Now to calculate the flow, we know design area multiplied by density. So what is the design area? For example, you have light hazard occupancy. The design area will be 1500 square feet multiplied by the density. What is the density for light hazard? 0.1 GPM per square feet. So you can calculate in this way. 150 GPM is the requirement for this design area. 150 GPM flow is the requirement for this design area. Theoretically, in this way, we can calculate. And when we add the hose allowance, then we get the total demand. Based on the light hazard, you will add the hose allowance. For example, if you consider the extra hazard 2500 square feet multiply by, if you consider group 1, it will be 0.3 GPM per square feet. So total requirement will be 750 GPM. See how much difference we are getting here. If you consider light hazard with this for the same area, for the not for the same area, but if you consider the light hazard, you are getting 150 GPM requirement, and if you consider extra hazard, you are getting 750 GPM requirement. So the flow is increasing if we increase the hazard classification. So always make sure to select proper hazard in line with NFPA 13. We already discussed that NFPA 13 has given few examples to select the type of hazard. So based on that, we need to select properly the hazard classification. So these are the few things to be kept in mind, and the other things I'll explain you in next slide. Before we select the design area, okay, the next point will be you need to remember the formula length of the design area. Length of the design area formula will be 1.2 multiplied by square root of design area. So what is the meaning of length of the design area? So again, if you see this figure, this is the remotest floor. And I told we need to consider the design area. So this is the design area. So what is the length? Any one side will be the length, the other side will be the width, right? I will explain you which has to be considered the length, which has to be considered as width. But for now, just remember one side will be length, the other side will be width. So initially, we know the design area requirement like light hazard 1500 square feet. But what should be the length to be considered for the remotest area? So you already know the area means length into width, right? So length, if we know the area, design area, then we can easily calculate the width of the design area. So just remember this formula, length of the, we have to use this formula in all the scenarios. So just remember this formula, length of the design area will be equal to 1.2 multiply by square root of design area. So design area can vary, like for example, 1500 square feet for light hazard, 1500 square feet for ordinary hazard, 2500 square feet for extra hazard. Why I am repeating these regularly? Because these are the most important requirement. Without knowing this design area, you cannot able to select the design area, and also cannot able to perform the calculation. So You have to remember these concepts. Okay, now you know the formula, you know the length of the design area formula, you know the basic concepts before we select the design area. And also there are one more formula is there. But before that, if you look at this thing here, just a moment. Here, theoretically, we are getting 750 GPM for the extra hazard occupancy based on this area and density. But in practical scenario, or when you perform the hydraulic calculations, the flow may be same or the flow may be more because of the frictional losses. Okay, actual scenario may be slightly more than this. This is the minimum requirement based on the theoretical demand. In actual scenario, this may be more. Okay, always try to add hose allowances with the sprinkler demand to get the final requirement for the sprinkler system. When to add the hose allowance, when we should not add, I already explained you. If you don't remember, just go through our previous sessions. But just uh, f- for a moment, if you want to know, like hose allowance will not be considered if your pump is dedicatedly supplying to the sprinklers and there is no standpipe system or fire hose cabinets or landing walls, whatever you call. If there is no hose system in the building and the pump is serving only the sprinkler system, then we can ignore hose allowance. Otherwise, under normal circumstances, we have to add hose allowances to the sprinkler demand. Okay, so now let's move with the main topic. Okay, now the other formula. This is also very important. You have to remember this or you can make a note of this. So, number of sprinklers in the design area. Okay, so the formula will be design area divided by coverage area of sprinkler. This is the most important formula. These two are the most important formulas you have to remember. Means you know we know design area of operation. Design area of operation means this is the design area. Coverage area of the sprinkler depends upon the hazard occupancy. As you know, like for light hazard, the coverage area will be, if you are performing the hydraulic calculations, you can consider 20 square meter per one sprinkler. For ordinary hazard group 1 and group 2, you can consider like 12 square meter. For extra hazard, this is the maximum requirement, maximum coverage area for the sprinklers. If you have extra hazard or high piled storage hazard, I mean this is for storage occupancies, but for extra hazard, you consider maximum 9 square meter coverage area per sprinkler. Okay, so here, if you look at this one, number of sprinklers in the design area. So you can calculate based on this formula how many number of sprinklers are required in this remotest design area. Okay. So here, design area. What is the design area? 1500 square feet for light hazard, right? Divided by coverage area of sprinkler. Coverage area you already know, 20 square meter for light hazard. So you will get some value here, right? So 150 by 2. How many sprinklers you will get? Like 7.5, right? If I'm not wrong, just a moment. So 150 divided by 2. Sorry, we are getting 75. Yeah, but the point is like, the point is like here the units are square feet, right? But this is 20 square meter. So you cannot use square feet and square meter. Both units are different. So what you need to do, 1500 square feet divided by, you need to convert 20 square meter to square, sorry. Oh my God. Just a moment. Okay, it's gone, I think. Just a moment. Okay, so you know the formula length of the design area is equal to 1.2 root into design area. The formula for number of sprinklers in design area is equal to design area divided by coverage area of sprinkler. So I told you 20 square meter for light hazard, right? But this is in square meter. This is metric units. But I told you design area in English imperial units. So 1500 square feet. So both cannot be different units. So whenever you use the formula, always make sure to use the same units. So for 1500 square feet, the coverage area, if you convert the square meter into square feet, it will be 225. Okay. Just a moment, because as per NFPA 13, it is 225 square feet we need to consider. So 20 into 10.76. Yeah. So if you convert 20 square meter into 10.76, so the conversion factor is 10.76 for square feet. So we are getting around 215 square feet. But we'll consider 225 square feet based on NFPA 13 if you are using English units. So now you will get the number of sprinklers like 1500 square feet divided by 225, you will get like 6.66. Always make sure to make it as round figure. So 7 sprinklers are required for the design area of operation. So 7 sprinklers are required in this design area. So 7 sprinklers to be considered for the purpose of hydraulic calculations. So in the event of fire, these 7 sprinklers will be activated initially. Based on this, we will calculate the flow requirement for the sprinkler system. Okay, so now you consider, like, for example, coverage area as 100 square feet. Okay, this will be for extra hazard, right? So 9 square meter in metric units. So 100 square feet will be in the English units. So the design area divided by coverage area. The formula for this, again, design area for extra hazard will be 2500 square feet and the coverage area will be 100 square feet, right? So we will get 25 number of sprinklers. See, 25 number of sprinklers to be considered for the, if you have extra hazard occupancies and if you are performing the calculations, so then you need to consider minimum 25 number of sprinklers. Okay. So this formula, now the catch point. This formula is applicable if you have uniform spaced sprinklers. Okay. Uniform spaced sprinklers. Please make a note of this. Uniform spaced sprinklers. Because if the sprinklers are non-uniform, in practical scenario, in most of our projects or in almost all our projects, the sprinklers are not spaced uniformly. The distance between the sprinkler varies, right? For example, here you will have 10 feet, here you may have 12 feet, here you may have like 9 feet distance. So the sprinkler distance is not uniform, then this formula is not applicable. If the sprinkler spacings are uniform, then this formula is applicable. Or if you want to theoretically calculate number of sprinklers required, you can consider this formula. Okay, as a thumb rule, you can consider this formula. So now again moving back to the other example. So now you have now you don't know what is the hazard occupancy. Okay, just you are considering like the design area. For example, only as an example, 1500 square feet and the coverage area is 100 square feet. For light hazard, I told you 225 square feet, right? For example, in your project, you are, for example, ordinary hazard. Consider it as ordinary hazard now. For ordinary hazard, 130 square feet is the coverage area per sprinkler. If you convert into metric units, it is 12.1 square meter. So always make sure to select the proper units. When you are considering the design area in English units, always consider the coverage area also in English units. Okay, so now design area 1500 square feet, coverage area as per the drawing is 100 square feet we consider. Okay, so because maximum 130 square feet for ordinary hazard, but we are considering only 100 square feet in our design because of the clashes with the other services like you have lighting fixtures or HVAC grills. Then okay, you have reduced the coverage area for the sprinkler because of the obstructions. So for example, you got the design area 1500 square feet, coverage area per sprinkler 100 square feet, and your sprinklers are uniformly spaced. Then again, to calculate the number of sprinklers, the formula is the design area divided by coverage area per sprinkler. So design area will be 1500, coverage area per sprinkler will be 100. So 15 sprinklers you need to consider for the purpose of calculation. So 15 sprinklers is the minimum to be considered to meet the design requirements as per NFPA 13. Now let's move to the other scenario. Okay. So, okay, one more important point I just would like to highlight you. As I told you, like length of the design or area, here we can see length of the design area is 1.2 times root of design area, right? So length of the design area, how to select the length of the design area? For example, this is the room. Here you are seeing this is a room and the pipe is coming in this way. Consider as tree system. Assume this as tree system and your sprinklers are spaced in this way. Okay, so now for example, this is the design area. Okay, this is the design area. So the length will be always, length of the design area will always be parallel to the branch line. So always make sure to consider this side as the length. Okay, you understood my point? You got my point? So whenever here you can see the distances, right, between the branch lines. This will be considered as width. Okay, this length will be considered as width. The length will be always parallel to the branch line. So this will be the length. This will be the width. Okay. So this is the most important point. Just remember this point as well. And then let's move to the next point. So now what is the shape of the design area? So you have to remember all these concepts. These are the most important concepts. You will not find anywhere on YouTube or you will not find this material. Everything here I'm explaining you based on my experience. And if you go through NFPA 13 also, you will not be able to understand these concepts. Okay, so I'm making it simple so that you can understand. If you are getting any doubts, just let me know. Okay, so now you know how to calculate the design area, you know the density to select based on the hazard requirement, and you also know how to calculate the number of sprinklers in the design area. So till now you understood the hazard classification. If you have light hazard, what should be the design area, what should be the design density in this remotest area, and what should be the flow to be considered theoretically, and how many number of sprinklers to be considered in the design area for the purpose of calculations, which will activate during the event of fire, and how to select the length. Length will be along the branch line, length of the design area. Width will be the opposite side. So if this is width, this is length. If this is length, this is width, right? Okay, so what should be the shape of the design area? Whether it should be irregular shape, the design area shall be rectangular shape or square shape. I'm trying to explain you now. Okay, so now let's assume, okay, before that, here I'll write this formula. Length is equal to 1.2 times root of design area. As I told you, this formula is applicable for uniform spaced sprinkler. If you have non-uniform spaced sprinklers, I will explain you in the next slide. So here 1.2 times root design area. So now, for example, 1.2 times of design area for light hazard is 1500 square feet, right? So length will be 1.2 multiplied by root 1500. So the length will be 46.47 feet. So this length will be 46.47 feet. If you know the length, you know area is equal to width into length, right? So you know the area, you know the length. Now you can calculate width. Width will be area divided by length. What is the area? 1500 square feet divided by length. What is this? 46.47. So 1500 divided by 46.47, you will get 32 feet. So it means our design area is 46.47 feet and the width is 32 feet. If you have uniform space sprinklers, you need to consider in this way the design area, and this will be rectangular shape. In most of the cases, we will consider rectangular shape for the design area. However, we will consider L shape and stepped shape as well. I will explain you this in other slides. But for now, just remember, in most scenarios, we will consider design area as rectangular shape. Okay. So as I told you, length is always parallel to the branch line. Just remember this point. Length is always parallel to the branch lines. Okay. Now one more point. If any doubts, you can interrupt me in between and you can unmute and you can ask me the question. So now we were discussing several times like the design area will be always in the remotest floor, right? Remotest floor and remotest area. But the point is like if you have the floor with half portion light hazard, half portion extra hazard. For example, here you have several rooms. For example, you have light hazard as well as extra hazard in the same floor, and this is the remotest floor from the pump room. Okay. Now, how many number of scenarios you need to perform the calculations? How many design areas you have to consider? It means for each hazard, you have to consider one scenario. Even if you have the remotest floor with extra hazard and light hazard, you have to consider extra hazard remotest area and perform the calculation. For example, your piping, just a moment. Your piping is coming from this way all along this. It is going to the light hazard and again it is going to the extra hazard. So you need to perform two scenarios because you have various hazards, right? Remotest floor, light hazard and extra hazard. So you will calculate extra hazard, you will consider the design area of operation. You know how to calculate the design, know the design area, you know the density, you know how to calculate the length, you know how to calculate the width if you have uniform spacing sprinklers. So based on this, you will perform the calculation, you will get some results at the inflow node. And you have light hazard, you will perform the remotest area, you will select the remotest area and perform the calculation. So here in this case, you will consider two scenarios. But in your project, if you have 10 floor building, for example, I am explaining you various scenarios so that it will be easy for you when you perform the calculations. Now you have you have light hazard in first floor and all the other floors, or for example in second floor you have one room with mechanical room, so this comes under ordinary hazard, right? Other area like for example offices, so light hazard, this is ordinary hazard. And the last floor, or for example, yeah, last floor, for example, you have extra hazard, overall floor will be extra hazard, for example. So just a moment. Yeah, so first floor you have light hazard, other floors all light hazard, for example, assume. And in second floor, one room you have mechanical room, which means ordinary hazard. And the other floor, maybe it may be the remotest or not, that would be fine. For example, ninth floor is the extra hazard and 10th floor is again light hazard. So in this scenario, how many number of calculations you will perform? Even though your extra hazard occupancy is not in the remotest floor, you have to calculate the hydraulic calculations considering ninth floor extra hazard area, because in extra hazard the flow requirement will be more, right, as compared to ordinary or light hazard. So one scenario will be considering extra hazard, one scenario will be considering remotest floor and remotest area of light hazard, one scenario will be considering remotest floor, that may be remotest floor, that may not be remotest floor. But if you have different hazards, then you have to consider that scenario and perform the calculations. Okay, so now you just remember these things. So if you have various hazard occupancies, you have to consider different scenarios for performing the calculations to get the proper flow requirement at the inflow node. Then only we can able to select the pump requirement. But as I already told you, if you have hydrants in your project, if you have fire hose cabinets, and if you have sprinklers also, then you need to select the highest flow and highest pressure to select the fire pumps. Okay, now let's move to the another slide. So now design area of sprinklers, I will consider one example. Okay, and then I will explain you. Okay, so there are steps to be followed when selecting the design area. Okay, steps, these are the standard steps to be followed when selecting the design area. So I'll give me a second, I'll try to draw the floor. This is the floor. Okay, and the length of the floor or the room is 150 feet, and the width of the room or the floor is 65 feet. Okay, so just don't miss any point here, most important concept. And you are having the pipe coming from somewhere, from the pump or from the network, and you are you know how to distribute the sprinklers, so you already distributed the sprinklers. Okay, and for example you are having like 5 sprinklers, 2 3 4 5, 1 2 3 4 5. Just distribute the sprinklers. You have distributed the sprinklers. Okay, similarly here, everywhere. Okay, you have distributed the sprinklers. Now I'll take some other color. This will be the S 13 feet. You know already area is equal to S into L, right? Coverage area of the sprinkler will be S into L. So along the branch line, you consider as S always. Okay, just remember this point. And between the branch lines, we consider as L. Okay. So now, for example, I consider 13 feet as S and 10 feet as L. Now I need to select the design area for this particular floor or room. So based on this, I got, based on these dimensions, for example, I got 70 sprinklers required in this entire floor. Okay, but the design area will not consider 70 sprinklers, right? We will consider based on the design area of operation. Like 1500 square feet, how many number of sprinklers we get, we'll consider for light and ordinary. 2500 square feet for extra hazard, we'll consider how many number of sprinklers we get, based on that we'll consider. However, there is formula, three-step formula to be considered when we select the design area of operation. Okay, so now assume that your occupancy hazard is ordinary hazard group 1, spacing along the branch lines means S, right? Along the branch lines, S is 13 feet and spacing between the branch lines is L 10 feet. Here you can find the spacing uniform. It means, see, S is uniform. In this example, S is uniform, L is uniform. It means everywhere we consider S 13 feet, L as 10 feet, and half of S will be from the wall, right? Half of S will be the sprinkler from the wall will be half S. This will be half L. So if you have in this scenario, right, the one which we explained before is also the same one, but here I'm explaining you the three-step formula, so it will be easy for you to remember. So the first step, to select the design area, we need to know the number of sprinklers in design area, and the sprinklers are uniformly spaced, right? So you already know, based on our earlier slides, design area divided by coverage area of sprinkler, we will calculate the number of sprinklers in the design area. So the design area based on this occupancy hazard, it is 1500 square feet divided by coverage area. This is the actual coverage area. Previously we discussed about the theoretical coverage area, right? Here we discussed theoretical coverage area based on the hazard classifications. Okay, like for example, extra hazard maximum coverage area is 100 square feet. For ordinary hazard, maximum coverage area is 130 square feet. For light hazard, maximum coverage area is 225 square feet. So these are all maximum coverage areas, but actual coverage area based on the design. So now actual coverage area will be S into L, right? So S will be 13 feet, L will be 10 feet. So we'll get around 11.5 sprinklers. So we'll make it round off to 12 sprinklers. So 12 sprinklers should be considered for our design. This is the first step. Now going back to the second step. Okay. The second step for selecting the design area is calculating the length of the design area. Okay. Length of the design area. You already know from the previous slide, 1.2 times of square root of design area is nothing but length of the design area. So 1.2 times 1500, because here we say ordinary hazard occupancy. So 1500. So we will get 46.47 feet. This is the length. You know the number of sprinklers, you know the length. Now, the third step would be to locate the sprinklers on the layout, right? To locate the sprinklers on layout. So to select the sprinklers on the layout, so 46.47, right? So I will draw in the next slide, you will easily get. So first step you understand, second step you understood, third step locate the sprinklers on this layout, right? On this layout. So how to select? So now here if you see, we got the length along the branch line will be 46.47. So from this wall, we just come down because this is 65 feet, right? So the 46.47 will be somewhere here, right? So this is the length. I will draw in the next slide. Just remember this is the length 46.47 and you need to consider 12 sprinklers, right? So here, if I consider this length 46, how many number of sprinklers I am getting in 46? 1, 2, 3, 4. So from 12 sprinklers, I already got 4 sprinklers here. So I just need to extend this one. I just need to extend this line. So here I got more 4 sprinklers. So total 8 sprinklers. Again, if I extend, I have more 4 sprinklers. So 12 sprinklers. So it matches with our number of sprinklers in the design area. So 12 sprinklers will be this area. So I'll just draw in the next slide. You will understand the point. So this is the thing. Room piping. So 5 sprinklers, right? 2, 3, 4, 5. Again, you have 1, 2, 3, 4, 5. Same example. I'm considering 2, 3, 4, 5. 2, 3, 4, 5. Now, as I told you, length of the design area will be remotest floor, remotest area. So we know this one 65 feet, right? The floor area. This is 150 feet. So our length of the design area will be based on the previous slide 46.47. So from this remotest sprinkler wall, you just come down. Okay, so 46.47, for example, it comes here. So just mark it 46.47 feet. And then see, always remember sprinkler coverage will be like in this way. So halfway this side, halfway this side. Okay. So always remember this point. So coverage area will be, we will consider half this way. So total length will be like this. Total length of the width of the sprinkler will be like this. So if this is L, this is S. Okay, so total will be L, but half L and half L. So it means this is half L and this is half L. Combined, it will be L. So here this side also, this will be half S, half S. So total will be S. So sprinkler will be always be, we will consider in this way. Half coverage this way, half coverage this way. Okay. So here based on this, from these two sprinklers, this is the halfway, right? Okay. Now this area you already got. So 46.47 and this area you got, this length you got, right? So now 4 sprinklers you consider. I will select the other. So 1, 2, 3, 4 sprinklers you got. Now extend this line till this half again. Okay, sorry, till this half. So you got more 4 sprinklers. So This area is also covered. So total 8 sprinklers. 4 plus 4. Again, you will extend this to half. Again, 4 sprinklers. So total 12 sprinklers. So in this way, you need to consider the design area. Now, now the one thing you need to remember, 12 sprinklers, okay, you got. Length also, you know. What should be the width? Width in theoretical sense, I explained you how to calculate the width. But in practically, if you look at this one, this will be the actual width. Okay, this x, whatever x we are getting, this is the actual width of the design area. This is the actual length of the design area, and number of sprinklers will be 12. So this is rectangular shape. There are various scenarios. I will explain you. So just remember, in this way, we need to locate the number of sprinklers. Okay, you may ask like, can I select, because this is the design area, right? This is the design area. You may ask, can I select this sprinkler, and this sprinkler? No, you cannot select. Okay, because the design area will be based on the length, right? Length is maximum 46. So you just need to select these 4. Okay, 4 sprinklers. When you need to select this 5th sprinkler, I will explain you later on. But just remember, you need to select these 4 sprinklers and just extend this line. That's it. Extend this line. Whatever is coming in between, you just take those sprinklers. Okay. Most of the designers, what they do, if they don't know the requirement, they will select, for example, 5 sprinklers. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the line. This is the row. So most of the designers, when you review the design, you have to check these points. That's why I'm explaining you. Most of the designers, what they do, just design area means they'll consider all the sprinklers in the loop or the branch. For example, here you have 5, irrespective of the length. They don't calculate the length, just they calculate total length of the room or the floor or the number of sprinklers in the branch lines, and just they will calculate 1500 square feet from here, and just they will proceed with the calculation. You cannot do in this way. You need to make sure there is a limitation of the length when you select the design area. Okay, limitation of the length and limitation of the sprinkler also. Sprinkler, okay, maybe it can increase to 13 or 14 depending upon the spacing of the sprinkler, but the length cannot exceed 46.47. Just remember this point. So based on this topic, the shape of the design area will be mostly rectangle. Okay, there are other scenarios I will show you. So it will be rectangle. Okay, just remember this particular point. Any doubts till now?
No doubts, continue.
Excellent. Okay, fine. So let's move ahead with the next topic. Now, just a minute. Okay, now the other scenario is like impact of cross main on design area. What does it mean? I will explain in just a moment. Previously, we told like, or we have seen an example where our pipe main line or the cross main is coming from the wall and it is circulated or it is connected to the sprinklers, right? So based on this, we consider the design area. But now if your cross main is in between somewhere, like, just a moment. If your cross main is coming from this way, not from the wall, and it is connected to the sprinklers, two on the left side and three on the right side, for example. So if your cross main is in this way, how to select the design area? So the procedure is simple and same, but here you can see most of the designers will do mistake. They will select this entire area or whatever, for example 46.47, right? They'll select like all these sprinklers because these are the remotest sprinklers, right, from the pump. So that's why most of the people or the designers or the contractors, what they do, they select all these sprinklers for the purpose of calculations. That is not correct, because if you come from this pump, the pipe is the remotest sprinkler will be this one, right? Assume that this is the remotest sprinkler. Mostly this will be the remotest sprinkler. So when you select the design area, you need to make sure to select the highest pressure as well as highest flow demand sprinkler. So now based on this remotest sprinkler, this is the highest pressure, right? So this is the highest pressure demand, but the flow will be highest flow demand will be this one, not this one, because I will just write it down here. So just remember, when you select the design area, you need to check for highest pressure demand and highest flow demand. So highest pressure demand means the sprinkler, this is the highest pressure because this is in the remotest location. But highest flow demand is not this one. If it, I mean, it's not this one. If this one is coming inside the length of the design area, then that's fine. But if your length of the design area is till here only, okay, till here only, then you will not consider these sprinklers. So the length of the, I mean the width of the length of the design area 46.47. If it comes till here, you will consider one sprinkler, two sprinkler, three sprinkler, four sprinkler. Similarly, how we followed for this, even though the main line or the cross main is in the wall or in between the room also, you have to consider this loop, but the design area, there is no change to select the design area. Okay, so everything you'll select in this way. Even if your cross main is moved from the wall, the design area procedure is same. Just remember this point. Design area procedure is same as I explained you in the previous slide. Now you have two cross mains. Assume that you have two cross mains, means one cross main is from this way, you have the sprinklers, the other cross main, both are not connected. Okay, so in this way, for example, if you have two cross mains and these two connected together and it is going to the pump or whatever it is, the source. Okay, so if you have two cross mains, how you need to select the design area? So basically the formula which I explained you, everything is same, but based on this formula, okay, I will explain. Here you have, for example, 140 feet length and 65 feet width. Okay, so based on the formula, number of sprinklers in the design area will be design area, remotest design area divided by, for example, if this is an ordinary hazard, so 130 square feet, Maximum coverage, I'm talking about the maximum coverage. So 12 sprinklers you need to consider, right? And the number of sprinklers on the branch line. These two formulas we already discussed in the previous slides. So I'm not writing the formula now. So number of sprinklers on the branch lines is length of the design area divided by sprinkler spacing. Sprinkler spacing along the branch line. So length of the design area will be, you already know, 1.2 into root times of design area divided by sprinkler spacing of the branch line, S. Okay, S is 13 feet. Assume this S as 13 feet. Okay, so we got 4 sprinklers here. In each, on the length, you need to have 4 sprinklers. And basically, if you look at this one, just a moment. Here, 1, 2, 3, 4 we consider. If you go back to the same example I'm considering, if you go back to this also, you selected 1, 2, 3, 4, 4 plus 4 plus 4, right? Total 12 sprinklers. But in new scenario, in this scenario, you are having 2 cross mains, but you have only 3 sprinklers here. But you need to consider 4 sprinklers on each branch line. So what you will do, you'll consider this sprinkler. You cannot consider in this way. If you are having 2 different cross mains, you need to consider any one cross main. But obviously, this cross main has 3 sprinklers. This cross main has only 2 sprinklers, right? So obviously, this will be the remotest sprinkler. So these 3 sprinklers will consider. So 3 will not consider 4 here, even though the formula says we need to consider 4 sprinklers on each branch line, because there are no sprinklers connected to this branch line. We'll consider only 3 sprinklers in this scenario, and then you'll go back 3, again 3, again 3, again 3. So it will be 12. 3, 6, 9, 12. So these 4 branches you will consider in your calculation, and the length will be obviously, just a moment, length will be 46 feet. Okay, but if the 46 feet, for example, if you are getting here the 46 feet, then you should not consider this sprinkler. Okay, you should not consider this sprinkler. Only you need to consider these 3 sprinklers, and because as I told you, this will cover half, this will cover half. So your design area length will be till here only. So the revised design area length will be X. The revised design area width will be Y. Okay. So X into Y, whatever you got, that should be the design area. So minimum design area will be 1500 square feet, right? So this X into Y should always be more than or equal to 1500 square feet. It cannot be less than 1500 square feet. I will explain you with an example in the next slide about this. But just remember that if this remotest line or the cross main is serving only 3 sprinklers, even though based on the formula we need 4 sprinklers on the branch line, we consider only 3 sprinklers because there are no sprinklers connected here. So 3 again will go back, again go back, go back. So this sprinkler, in between you draw a line, and this length you already know 46.47. But if this sprinkler is getting in between, don't consider this one. Just make it a line, create a line in between these 2 sprinklers and just draw in this way. You will get this length and this width. So length into width should be more than 1500 square feet for ordinary hazard, okay, or light hazard occupancy. Now, next topic will be, now we discussed about the rectangular shapes, right? We'll discuss about L shape and step design area method. Still, we did not move with the non-uniform spacing of the sprinklers. Here we are discussing only if you have uniform spacing of the sprinklers. Now we will discuss non-uniform spacing of sprinklers. If in your project the sprinkler spacing is non-uniform, then how to select the design area? We will discuss that one. Okay. So just a moment, I will go to the next slide and draw the figure. Meanwhile, if you have any doubts, you can just let me know. Okay, now let's discuss L-shaped design area and stepped design area. So this topic will be, just a moment. I will share the notes with you guys so that it will be easy for you, but you have to go through this video again to remember all the concepts. L-shaped and stepped design area, okay, or irregular shaped design area. Like, okay, in real world projects, obviously we find irregular shaped or non-uniform spaced sprinklers, right? They will not be uniform spaced sprinklers. However, before we move ahead with the non-uniform spacing sprinklers, I will just cover this L-shaped and stepped design area. So now assume that you have a floor or a room 130 feet length and width of the room 50 feet. Okay. And now the occupancy hazard of the room is group 2 ordinary hazard and S is 10 feet, means length of the distance between the sprinklers along the length of the branch line is 10 feet. Between the branch lines is L is 13 feet. Okay, so here I'll just try to draw once again. So here 1, 2, 3, 4, 5. You got 5 sprinklers. This is the length, sorry, cross main. And now you just draw here 1, 2, 3, 4, 5. One more. Okay. Now how to select the L shape or how we get the L shape or stepped area? I'm just showing it to you. Previously we selected the rectangular shaped area. Okay, so now as per the example, L will be this spacing, right? Distance between the sprinklers between the branch lines is 13 feet, which is L. Here also you will have the sprinklers, okay? I'm not drawing here. S is equal to 10 feet. Okay, so S is 10 feet, L is 13 feet. You know the formula, number of sprinklers in the design area is equal to design area divided by coverage area of the sprinkler. So here coverage area is S into L. S will be 10 feet, 13 feet is the L. So we got 11.5 again. So 12 sprinklers we need. I am considering the similar examples so that you will easily understand the points. So length of the design area will be 1.2 root times of design area. So 1.2 root times of 1500, you got 46.47 feet. And the third point, number of sprinklers on most remotest branch line, means on the length of the branch line, what is the how many number of sprinklers to be considered. So length of the design area divided by S. Okay, so length of the design area is 46.47 divided by S. S is 10 feet, we know from the drawing. So we are getting 4.64. So 5 sprinklers we need to consider. Now, if you look at this design, we considered 5 sprinklers on the branch lines. 1, 2, 3, 4, 5. We consider 5 sprinklers. So our length will be 46.47, and on the branch line we need to consider 5 sprinklers, right? So to match both of these, entire area should be considered because this is 50 feet, right? Our requirement is 46.47, but we need to consider 5 sprinklers, right? So 1, 2, 3, 4, 5. All these sprinklers we need to consider. So this will be the length, right? So here you got like 46, here you got, for example. Just extend this line. So till here, 46.47 feet. Now, I hope you are getting my points. Here you can see 50 feet is the width of the wall or the room. So 46.47, here you can see 46.47, it will cover total 5 sprinklers. Okay, because we need 5 sprinklers. So length of the branch line will be 46.47, 1, 2, 3, 4, 5. And just as I told you previously, you need to extend this one, right? So you need to extend this rectangle again here. But now you see, when I consider this rectangle, I got 5 sprinklers. Again, I consider this rectangle, I got more 5, so 10 sprinklers. Again, if I consider this rectangle, I'll get more 5. So 5 plus 5 plus 5 will be 15 sprinklers. But our requirement is maximum for the purpose of calculations. It is 12 sprinklers, right? Based on this example. So which 2 sprinklers you will consider? So till here it is clear. Like in between these two, this is the remotest area. This area is clear. Again, this area is also clear. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sprinklers. But which 2 sprinklers you will consider now to make it 12? You will consider these 2 sprinklers or these 2 sprinklers? Mostly people consider these 2 sprinklers, or the designers consider these 2 sprinklers. That is not correct. We have to consider the 2 sprinklers which are near to the cross main. Okay. So how I can say, because as I told you in the previous slide, you need to make sure for design area, you need to select highest pressure demand and highest flow demand. So highest pressure demand, you already from the remotest area, remotest point, you get highest pressure. But highest flow you will get from near to the cross main, right? Because all these sprinklers are already selected. So you have these 2 sprinklers here. So you need to select these 2 sprinklers for the design area. So select these 2 sprinklers. Now 5 plus 5 plus 5 is 12 sprinkler. You cannot consider these 2 sprinklers. You have to select these 2 sprinklers. Okay. So this is the proper method which I am explaining you. I hope you guys are getting my points. So this is like L shape, right? If you see here, this is L shape area. So this is the actual design area. This design area, as I told you again, shall be more than or equal to 1500 square feet for light and ordinary, 2500 square feet for extra hazard. So you need to measure the dimensions and get the area. Okay. So based on that, you need to verify. You have to satisfy this condition also. Even though your sprinklers are like 12, your sprinklers are 12 and the length also you properly considered. But if your design area is less than 1500 square feet, you need to add one more sprinkler. This is also an important catch point. So you need to add one more sprinkler or two more sprinklers to make it to 1500 square feet. Sometimes it happens. I will explain you. Sometimes it happens that even though you consider 12 number of sprinklers and you have done properly the design area, when you calculate the design area, it is less than 1500 square feet. Maybe you got 1460 square feet. Okay. Then you need to consider one more sprinkler to make it or to make it 1500 square feet or greater than 1500 square feet. So 1460 plus one sprinkler coverage area under here you can see 10 into 13, right? 130. So it will be like how much? 1460 plus 130 will be 1590, right? So which is greater than 1500 square feet. So it means you need to consider one more sprinkler for the purpose of calculation. So it will be 13 sprinklers. So this is for the uniform spacing. S is same and L is same in your entire floor. Then this is the procedure. If it is non-uniform, the procedure is different. I will explain you the thing about that. Okay. Now, since you have cross main near the wall, you got like L shape, right? But if your cross main is in between the wall or in between, I mean, from the cross main, your sprinkler is connected on one side and the other side as well. On two sides, if your sprinkler is connected, then how to select the design area? So just a moment, I'll try to draw again. So you have to revise these concepts. Anyhow, I will share the notes with you. But those notes will not, I think you may not understand those notes because those were prepared by me. So maybe you may not understand. So just try to catch up from this video series or from this session. Okay, so now your sprinklers are connected here. Okay, so now your sprinklers are connected. You have a floor. Same example like previously. So you'll consider the same length. For example, in that length, you are getting all these sprinklers to be considered. So till here I'm getting, so I just extend this line. This will be my 46.47. And then now 1, 2, 3, 4, 5, right? 6, 7, 8, 9, 10. So this is my rectangle. Again, I draw the rectangle. This is my rectangle. Now, since the cross main is here, not in the wall, right? So when the cross main is here, as I told you, highest demand and highest pressure. For highest pressure, this is the remotest sprinkler. But for highest demand, you need to consider these two sprinklers to make it 12. You cannot consider this sprinkler or this sprinkler or these two sprinklers or these two sprinklers. You have to consider this sprinkler and this sprinkler which is near to the cross main. So 5 plus 5 plus 10 plus these two will be 12, right? So just a minute, I will consider some other color. Sorry, till here. So this is the step method for uniformly spaced sprinkler, like T you can see here. This is step method. So in this way, you need to consider if your cross main is here, if your cross main is like this and it is serving to from one side only to the entire sprinkler, it will be L-shaped, or you may get rectangle shape like how I explained you. You can consider rectangular shaped design area as well. I'll give a minute so that you can just discuss and let me know if you have any doubts, or we will move ahead with the other slides. These are the very important concepts you'll not find anywhere. This is all based on my experience I'm explaining you. So just go through these points whenever you start the design. Even if you perform manual calculations or using the software, you need to know these design area requirements. Okay, so let's move ahead then, if there is no doubt. So now, next topic will be design area validation. Design area validation. So as I told you in previous slide, like you need to make sure that whatever design area you are getting in actual as per the drawing, that should be more than the minimum design area requirement based on the hazard occupancy. So if your design area, whatever you got, is less than this actual minimum design requirement, then you need to add more sprinklers to make it or to increase the design area from the minimum design area requirement. So the design area formula you already know. Again, just for the purpose of reference, I'm telling you. Design area formula will be number of sprinklers in design area into coverage area of sprinkler. So number of sprinklers in design area 12, right? In our scenario here, and coverage area of sprinkler S into L. So you got like 1560 square feet. If you get 1560 square feet, which is greater than 1500 square feet, then that's fine. But if you get the design area less than 1560 square feet, assume that you got less than 1500 square feet, then you have to add one more sprinkler. So in this way, you need to validate the spacing of the sprinklers. I will explain you with in the next slide, so to make it clear. Okay, now let's consider how we'll get the less design area, even though we consider the number of sprinklers and length of the design area, everything we consider as per the formula. Even though we get the design area requirement less than the minimum design area, we will consider one example. Just a moment, I'll just try to draw. So you have a line cross main and it is served to 5 sprinklers. For example, again 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. So it continues like that. Okay, here also you'll have those sprinklers. Okay, so now the SC is like 10 feet, L is 13 feet. Previously, we considered the same. S has 10 feet, L has 13 feet. But previously, what we have done, we consider this as half L. From the wall, we consider this as half L. This as half S from the wall, this sprinkler. We consider the distance as minimum distance from the wall, or sorry, yeah, the distance from the wall we consider as half into S. S you already know, half into L. This is from the previous scenario. Based on that, we got the design area 1560 square feet, which is greater than or equal to minimum design requirement. But now we are not considering half L or half S. We will consider, like for example, for the purpose of example, 3.5 feet. Okay, from the wall, and here also we can consider less than 5 feet. Okay, less than 5 feet, for example. So this is 3.5 feet you consider. Just remember this point, because minimum 100 mm you can consider, right, from the wall to the sprinkler, first sprinkler. But we consider like 3.5 feet. this is in mm. 4 inch you can consider minimum from the wall. Minimum distance from the wall to the sprinkler is 4 inch. Maximum will be 2.1 meters. Okay, you can consider. But in previous example, we consider half L and half S, and then we got 1560 square feet and 1500, which is more than 1500 square feet design requirement. But here we are considering 3.5 feet from the wall. So the formula again, number of sprinklers in design area is equal to design area divided by coverage area of the sprinkler, 10 feet into 13 feet. So you'll get 11.5. So it means 12 sprinklers. This is fine. 12 sprinklers we need to calculate. Okay. And length of the design area, 1.2 times of root design area. 1.2 into 1500, we get like 46.47 feet. This also we know. Now number of sprinklers on most remotest branch line, length of the design area, this also you know the formula, divided by S. So 46.47 divided by 10, S is 10, right? So we got 4.64, so it means 5 sprinklers we consider. So here number 1, number 2, number 3, number 4, number 5 sprinklers. So 5, you just draw the rectangle, and then you will extend 10 and then 12, right? This is the area. But here now you got the design area. Now you need to validate the design area. Means whatever design area, actual design area we got shall be more than or equal to minimum design requirement, right? Minimum design area requirement based on the hazard classification. Okay, so now give me a moment. So now you just calculate this area. What is the area? So now here you have this area, right? Oh, okay. Just a moment. I'll explain. Here, this is the design area, right? Total design area. You need to calculate the area of the this thing. So here, this area 1, this area 2, and this will be area 3, right? So 1 plus 2 plus 3, these three areas combined, you'll get the total actual design area. So area of the larger rectangle, plus area of the small rectangle, this plus this, you will get actual design area. So area of the larger rectangle, when you measure, you got like, so area is length into width, right? So length is 50 feet multiply by what is width. 50 feet is the, here this is the 50 feet. Okay, so 50 feet multiply by length into width, right? Width is 3.5 feet from the wall plus 13 feet for L, plus, if you are getting confused here, just let me know. 13 feet plus half of the sprinkler also, right? So here you can see on right hand side, this is wall, right? From the wall 3.5. Again, this one is 13 feet between the sprinkler L, and you will consider this half, right? Because here if you see, it is 6.5. This will be 6.5. Then this combination will be 13 feet, right? So here it will be 6.5. So 50 into 23, you got like 1150 square feet. So 1 plus 2, since both are same, so I consider the entire rectangle with these two sprinklers. So I got 1150 square feet. Now I consider the small rectangle area. Small rectangle area, it will be, okay, here you see 1, 2. This is small rectangle area, right? 1, 2, 3, 4, 5. Okay. So I'll just try to draw. This small rectangle area you need to calculate, right? So this small rectangle area, this sprinkler half this side, half this side coverage area. This sprinkler half this side, half this side. We'll consider as I told you before, right? So here if you see the distance between these two is 10 feet, right? So 5 feet, 5 feet, 5 feet, 5 feet, right? So distance between these two is 10 feet. So 5 feet coverage, 5 feet coverage, 5 feet coverage, 5 feet coverage maximum, right? And this side, you are considering this rectangle, right? So from here to this middle point, it is 6.5. But till this sprinkler, it is 13 feet, right? So you need to calculate till this sprinkler 13 feet. So 13 feet and 13 feet multiply by 10 plus 5 plus 5. Just a moment. If you don't understand, just draw in AutoCAD, you will get this area. Okay, just draw in AutoCAD and calculate the area you will get. So small area rectangle will be 13 feet by, this will be 13 feet multiply by, here it will be 20 feet. How? 5 feet plus 10 feet plus 5 feet. This length is 5 feet, 10 feet and 5 feet. So it will be 20 feet. So 13 feet into 20 feet, it will be 260 feet. So 260 plus 1150. So area of the large rectangle plus area of the small rectangle. How much we got? 1150 plus 260. We will get about 1460 square feet. But how much is the minimum requirement for this hazard, ordinary hazard? It is 1500 square feet, which is less than 1460 square feet is less than 1500 square feet. That's why we will add one more sprinkler in our calculation. So in this way, you need to check whether your design area is in line with the minimum requirements or not. Okay. Even if you have step method, if you follow step method, then also you need to check the design area. So in this way, we can verify the design area requirements. Any doubt in this? Next topic will be most important because that will be uh, considered in actual scenario. All these scenarios, if you have typical rooms and if you have like mostly if you have upright sprinklers, then you'll not find any obstructions, right? Everything can be properly spaced, like in the parking garages, in the mechanical rooms, or if the room, if your spacing of the sprinklers in any room is uniform, then the method which I explained you to be followed. The three-step formula, like we will calculate the number of sprinklers in design area, length of the design area, and then you will look at the sprinklers on the drawing, and you need to verify the design area is in line with the actual requirements or not. So all these steps to be followed. The next topic will be non-uniform spacing. So all these are like concepts. So if you could go through all these things, then only you will understand these points. So there are a lot of things to be explained. Actually, what's the time now? 8:45. Okay, no issues. So, okay, let's move ahead with. If you have any doubts, just let me know. Otherwise, let's move ahead with the next topic. non-uniform spacing of the sprinklers. So here little bit the concept is little bit different. So I'll try to draw a simple figure first to explain this. You have a room, just a minute. You have a room and that room is distributed with sprinklers like 6 sprinklers. Let's draw 1, 2, 3, 4, 5, 6. This is cross main end cap 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So similarly, you will follow the distribution here. Okay. Now, assume that your spacing of the sprinklers varies. From the wall, you consider like 5 feet. There is no half S or half L here. And to this sprinkler, we consider like 12 feet, assume. The third sprinkler we consider 15 feet. See here, the S is not same, right? 15 feet here, again 10 feet. Again, we'll consider 12 feet. Here we'll consider like 10 feet. So if you see here, all these are not same. S is not same. And this is from the wall, it is not half S, right? And from here also, it is 5 feet, for example. So based on this, 10 feet, 12 feet, 10, 15, 12, S is different, right? Along the branch line is S, between the branch line is L, right? So now the concept varies. Okay. Now, length of the design area, this is fine. The first step is fine. Length of the design area is 1.2 times of root design area. This is fine. Length, this formula is fine. But the second step, like number of sprinklers in most remotest branch line, or the third step, whatever you call it as branch line, the formula which we discussed is number of sprinklers. So number of sprinklers, how many to be considered? This is the formula we consider for the uniform spacing, right? Length of design area divided by S. But this formula never works if you have sprinkler spacing differently, or if your S is different. Because here you can see S, if it is same, this formula valid or works. If the S is different, then this formula cannot be used. Now let's consider an example. Example of light hazard. And the design area for light hazard, 1500 square feet minimum requirement. And the sprinkler spacing is non-uniform. Sprinkler spacing is non-uniform. The first step, as I already told you, this is the formula, same formula. So 1.2 times root of design area means for light hazard also 1500 square feet, you will get 46.47 feet. This is fine. Then we need to draw a line up along the length till we get 46.47 feet. This will be calculated from the wall, starting from the wall, from the most remotest sprinkler. Okay, you already know this. We need to draw from here itself, from the remotest sprinkler, and extending parallel to the branch line. We need to extend this parallel to the branch line. So we need to measure 46.47 feet from this point, right? And now, how many sprinklers are covered in 46.47? This is the point. So 1, 2, 3, 4. Assume that the 46.47 is still here. So you'll consider 1, 2, 3, 4. but you don't know how many number of sprinklers to be calculated or considered. If they are uniform, then if you get 12 sprinklers, you will consider here 4, 4, 4. That's it. But now because it is non-uniform spacing of the sprinklers, there is a different methodology to be followed. I will explain you in a moment. Okay. So now here 4 sprinklers you need to consider, this you got, but total number of sprinklers, how many, you don't know. Right. So now, okay. Now let's move ahead with the next step. Okay. Here, before I move ahead with the next step, as I told you, we need to consider 4 sprinklers, right? Sorry, we got 4 sprinklers. We no need to consider 4 sprinklers. I will draw in the next slide so that it is easy for you. Draw a little bit big. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have distributed the sprinklers, assume 2, 3, 4, 5. 1, 2, 3, 4, 5. And the sprinklers are connected to the branch line until the cross main. Okay. Now we already know the distances from here. I am not drawing again these distances. It means the distances are vary 5 feet, 12 feet, 15 feet, 10 feet. All this is there. Okay. Now my thing, I'm explaining you a little bit differently here. So we just consider 46.47 feet, right? This length from here. So for example, we get till here. Now here we have 1, 2, 3, 4 sprinklers we are getting in this design area length, right? 4 sprinklers we are getting for now. But whether you need to consider 5th sprinkler or not, it depends upon this sprinkler, 4th sprinkler. How? I will explain you. So now here if you see, this is the 4th sprinkler, assume. This is the 5th sprinkler. And the distance, I told you, half of this and half of this coverage, right? Half of this coverage, half of this coverage, and half this side, half this side. Then it will be a rectangle. This is the coverage area of the sprinkler. So coverage area will be calculated in this way: half this side, half this side. Right? Here half, if you have sprinkler, one more sprinkler, half this way, half this way, half this way. So this is the coverage area. In this way, you will consider the coverage area of the sprinklers. Half this side, half on all 4 sides. So in this way, you will calculate the coverage area of the sprinkler. Now, if your 46.47 or the length of the design area is coming below this line, below this coverage. I mean, if I'm coming from here, if my line is here, okay, so it means we'll consider only 4 sprinklers. 4th sprinkler till 4th sprinkler. We'll not consider 5th sprinkler. But if your 46.47 feet is coming here, it means it crossed 4th sprinkler and it is arrived into the 5th sprinkler, right? The distance arrived into the 5th sprinkler. So it means we need to consider the 5th sprinkler as well. Otherwise, no need to consider 5th sprinkler. If you consider 5th sprinkler, then the length of the design area increases from 46.47 to somewhere around 56, for example, 56.5 feet. So this will be the revised length of the design area. So 56.5 feet is the revised length. In uniform sprinkler spacing, you are using 46.47, but if you have non-uniform sprinkler spacing, You need to use 46.47, but the thing is like the distance, if it is coming in this here, as I shown you before, if it is entering into the fifth sprinkler coverage area, then you need to consider the fifth sprinkler, otherwise consider up to 4 sprinklers. So assume that our line, design area line, is coming into the area of the fifth sprinkler, then we'll consider fifth sprinkler. So final length will be, we need to add from the wall how much, from the distance how much, from the distance how much, this distance how much, from here to distance how much. Okay. So, and from here you need to consider half also, right? Because the sprinkler is covered half here, half here, half here, half here. So when you consider fifth sprinkler, then you need to make sure that you consider this area as well. This area, half of the coverage area you need to consider. So here you have to consider till this point. So this will be, for example, 56.5 feet. This is the revised length of the design area. Okay, so now from here you got like 56.45 design area. You make a rectangle here. You got the rectangle. So 5 sprinklers you already got. But how many number of sprinklers you need to consider, still you don't know, right? Based on this. Okay, so now what we need to do, till we achieve 1500 square feet, we will continue this procedure. Now this area, what is the area? Like this area, for example, you got 621.5 square feet. This area, just measure this area, width into length. Length already you know 56.5 feet, and measure this width, you got, for example, 11 feet. Okay, so it will be 621.5 square feet area. So just extend this again, rectangle here. Now you are going like reverse engineering, you are doing to select the number of sprinklers, total number of sprinklers based on the design area. So now 621, again you consider 621.5. So how much you got, like 621 plus 621, you got 1242. Oh, sorry. 1242 you got. Just a minute. So this area 621, again this area 621, 1242. Again, if you add 621, how much you are getting? For example, you are getting 1862, which is way more than 1500 square feet, right? So you need to cut it till 1500 square feet. So which sprinklers you need to consider? You have to consider the sprinklers near to the crossmen, I told you, right? So here, irrespective of the number of sprinklers, now we are going to the design area. So based on the length and design area, we calculate the number of sprinklers. In previous cases, when the sprinklers are distributed uniformly, you consider length of the design area and number of sprinklers, and then you define the design area. But here, you define the number of sprinklers based on the minimum design area and the length of the design area. So here, if you see 621 plus 621, it is 1242 or 1241. So 1241 minus 1500, how much it will be? 1241 minus 1500, it will be 259. So we need to consider 259 square feet. So assume, based on the distances, you have to select one sprinkler, or sorry, 259 square feet, right? So maybe you need to consider 2 sprinklers based on this thing. So it means because one sprinkler maximum coverage area for light hazard is 225 only, right? But we require 259 square feet is missing. So it means more than 225 means we need to consider one more sprinkler, right? So now the revised design area, whatever you get, is greater than 1500 square feet. So whenever you are considering non-uniform sprinkler spacing, the steps will be calculate the length of the design area, and then based on the design area 1500 square feet or 2500 square feet for extra hazard, based on this you calculate the number of sprinklers. In uniform spacing sprinklers, you calculate the length and number of sprinklers and then you arrive to the design area. There 1, 3 and 2 steps followed. Here 1, 2 and 3, in this sequence we follow the steps. Okay, so in this way you need to calculate the design area, and based on this you will arrive to the number of sprinklers. How many number of sprinklers you got, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here also you got 12 sprinklers. But it is a coincidence that you got 12 sprinklers. You may get 13 sprinklers, 14 sprinklers, 15 sprinklers. We don't know. Okay, you may get 12 sprinklers also. We don't know about this until and unless you draw the figure and distribute the sprinklers and measure the coverage area and use the formulas to calculate the design area. Okay, so in this way you can calculate the design area for the sprinkler system. So there are other concepts also to be explained. So already the time is 9 now. So next session we are going to discuss about the design area adjustments. So if you are using quick response sprinklers, this one, as I told you, this is applicable to standard sprinklers. The design area concept is same, but the design area selection is different if you have quick response sprinklers, or if you are using high temperature rated sprinkler, if you are having a pre-action sprinkler system, if you are using dry system, then the concept is same, but the design area varies.